Hey guys, here's the notes for this little lesson, and I need to apologize. As I was going back over it, I realized it did not print anything like I thought it would. So there's a couple big things that it's missing. First of all, this sign here didn't even print. It just says this means congruent, and I thought it was a typo, but it should be that little equal sign with a squiggly mark on top. And then we get down here, and if we look at the notes here, I'm not going to read all this, you can do that. But down here, it says identify the corresponding sides. Corresponding just means the same relative position in two different shapes. So we want to identify the same relative position sides and angles in the two figures. The angle part didn't even show up. But for the sides, if I look at BC up here, this side corresponds to RP. And you just need to write the letters. You just write the letters RP. I'm going to change that and put the line over it. And then AC corresponds to NP. NP here. And those are the corresponding sides. Let me go to the black pen, that might be better. And then for angles, angle A is this one. It corresponds to angle N. Angle B corresponds to angle R. And you'll notice that corresponding angles should have the same measure. If they don't have the same measure, the shape is not similar. Now, again, it says find the ratio of these things. These letters didn't even print. Well, the ratio of AB to NR is AB is 12, NR is 8, so it would be 12 over 8, or you can write it 12 to 8. Either way works. Both of them are just fine, okay? So I'm going to try to move this over. Oh, it won't allow me to. There we go. All right. So find the ratio of BC to RP. BC here is 6. So I'm going to go 6 to, maybe I'll write the letter 6 to, and that's 4. And then CA to PN. CA is 15. PN is 10. So those are the ratios. Alright, let's continue. Just a quick reminder, you can write ratios a couple ways. One way to write it is like this with the colon here. Another way to write it is as a fraction. So you could do 15 over 10, 6 over 4. Both work. You could also say 6 to 4. You can use the word. Alright, so that's that part. That is really important. To be able to write a ratio of corresponding sides or corresponding angles. I'm going to try to pause it and move on to the next. Okay, so the next part was you needed to find the missing segment, and it said solve the proportion, and you'll notice, if you remember, the proportion wasn't even there. I really don't know what happened. So that's our proportion, and we want to solve it. So to set up this proportion, I can take corresponding sides, write the ratio, and then take another corresponding side, one that I don't know, and write that ratio, set the proportion up, and then I can do this little trick where I cross multiply and divide. So I would have 30 times 8 equals 15x. That becomes 240 equals 15x. I divide this side by 15 and this side by 15. And x would be 16 if I did that. So using a proportion allows us to find a missing side. Another way to do it would be to find the scale factor. 15 over 3, the scale factor is 1/2. So 8 is 1/2 of x, or 8 times 2 is x. So 8 times 2 is 16. So I could use scale factor as well. Let's do this one over here. Notice corresponding sides, 12 over 16, same relative position, x over 20. Alright, and then I can cross multiply and divide cross multiply and divide. And I believe if I do that, x, the product, or the answer should be 16 there for x. I'll do the same thing for y. I'm going to set up my proportion. I can actually use my new proportion, 16 over 20, because I now know that x is 16. 16 over 20 equals y over 10. Notice, 16 is from this triangle, y is from this triangle, they're both on top. 20 and 10 are from the same triangle, they're both on bottom. That's kind of important. So I cross multiply. 16 times 10 equals 20y. It gives me 160 equals 20y. I divide by 20. Those cancel. Divide by 20, and y equals 8. So that's how we can use proportions to find a missing side. Very important, very cool. Okay, here's the rest of the notes, the backside. So all you have to do here is set up these proportions and solve for x and y. Now, remember to set up a ratio and the proportion, you need to match up corresponding sides. So it's really important to be able to match these corresponding sides up. And 6.4 corresponds to 8 because you'd have to turn this triangle around to match up the angles. Make sure they're in the same relative position, and then it'll match up the sides. So 6.4 and 8. So I'm going to write my ratio. 6.4 over 8 equals, and then this one would match up with y, equals 14 over y. All right. Oh, I'm sorry. I put it in the wrong place. Look at that. That won't work, so that can't be 14 and y, because if I look at this, 6.4 is on top here, so y has to be on top. 8's on top there, so y, so 14 has to be on top here. Getting a little brain dead here at the end of the day. 14 goes there. Then I'm going to let you do this calculation. 14 cross multiply and divide by 8. All right, you can do the same thing for x. I'm not going to set that one up for you, but I'll move over to this shape. So here, it looks like it's in the same relative position. We don't know angle measures, so we kind of have to assume same relative position. We have, those are corresponding sides. 9 over 22.5 equals 12 over x, and equals y over 35. Again, you can just cross multiply, divide to figure out your x. Do the same thing for y, but to figure out y, we do 9 times 35 divided by 22.5 will give us y. Lastly, are the triangles below similar? To figure out if they're similar, the corresponding sides have to be proportional. So I'm going to take the corresponding sides, one of which is 14, and it's delaying a little bit for me. So I would take 14, let's see if a different pen will work, 14 over 8, and see, does it equal 10 over 5? Are those in proportion? Remember, to figure this out, I can do this cross multiplication. 14 times 5, 5 times 10 is 50, 5 times 4 is 20, 50 and 20 is 70. Cross multiply here, 80. Those don't equal, so this is not proportional. They're not proportional, which means they are not similar. Okay? So look for proportionality to see if two shapes are similar. And finally, just have a look at the bottom. Can you do these things? Describe the difference between congruent and similar figures. Congruent is the exact same size and shape. Similar, same shape, different size. Can you identify corresponding angles and sides? And can you calculate the missing side lengths in similar figures? Hopefully this helped a little bit. I really apologize for the bad page. Hopefully the bad copy. I'm hoping that that won't happen again. I am very brain dead, ready to sign off. I know this is long, but if you need it, it should help. All right. See you guys soon.